Hey guys, I'm going to give you a couple hints for the limit maze because there's a few questions on here that are a little tricky. So I'm going to start with this one that's question K, and I'm going to show you how to do these by hand, and then I'm also going to show you a way that you can use Graph or Desmos to help you. So like I did talk to you about piecewise functions and how to work with those in the last lesson, but then I didn't really explain anything like with absolute value functions, especially this one where we're approaching the value 4 but from the left side only. So here's what I'm gonna suggest you do. Here's option 1. You can look at what you're evaluating and you could pick a number that is less than 4, since we're approaching 4 from the left side, and you could plug that in and just kind of see what happens. So what is a number that's really close to 4 but slightly less? The first thing that comes to mind is 3.9. So I'm going to plug in 3.9 to my function, and I'm going to see what happens. So if I plug in 3.9, the top is going to be negative 0.1. And the bottom would be negative 0.1, but the absolute value of that would become positive. And so you'd get negative 1 when you divide those two things. Remember that limits are like you're getting really close to that value but never touching it. So I'm getting really close to 4, but in coming from the left side. So maybe I could pick a number that's even closer, still coming from that same direction, just as like a comparison to see if my answer from the first run through was correct. So I'm going to pick 3.99, and I'm going to do the same thing that I did with 3.9, just a comparison again. So this would be 0.01, negative 0.01, and then the bottom would be the same thing, but the absolute value would make it positive. And so I am getting negative 1 as my answer again. So then that means my limit would be equal to negative 1 for this one. On a graph. So I've got it already on Desmos. If you're really stumped, you can just graph the function like I have here and follow, the limit from as we approach 4 from the left side. So here I come. I'm approaching 4 from the left side, and I'm getting really close to negative 1. At 4, it's undefined because it's a piecewise function, or not a piece, yeah, well, it is a piecewise function, but it's also because there'd be a 0 in the denominator at 4. So as I get really close to 4, my values are getting closer and closer to negative 1 on the y-axis. So that just confirms that our answer was correct. Okay, here's another one where we're approaching a value from one side only. This is a piecewise function, and I did talk about these in a previous lesson or a previous video. However, this one's different. Do you see how the restrictions are not like x is less than something, x is greater than something? This one's a little bit different because this basically says that we're going to use this first function for any x value that is not negative 2, which means basically every single number will use this function, will follow that function, except for negative 2. Negative 2 is going to be equal to 0. Okay, when x is negative 2, it's going to be equal to 0. So anything that's not negative 2, you'll follow this guy. When you are negative 2, you'll follow this one. The difficulty is we're doing a limit as we approach negative 2 from the positive side, right? So that's, the negative 2 is where the function's restricted, and that's what I'm supposed to be doing the limit for. So we could use the same trick as before. We could pick a number that is close to negative 2, but would be like on the right side of that. So right side of negative 2, something really close coming from the right side would be negative 1.9. And so maybe you could just plug negative 1.9 in. That would classify as the top function, since negative 1.9 is not the same as negative 2. And so if we plugged that in, negative 1.9 squared plus 6, negative 1.9 squared plus 6 would be 9.61. Okay, it's a very weird answer. And remember, we're doing a limit as we get closer to -2, so maybe this isn't the most accurate answer we could get. Let's try another. Let's try like what we did last time and plug in -1.99 and see if it changes. So 1.99 squared plus 6 gives you 9.9601. Okay, so it's different. It's still somewhat close to 9, but it's increasing. So I'm going to do it one more time, and I'm going to see if I can come to a conclusion. I'm getting even closer to -2 with this next value that I'm choosing, but I want to see if I can get even a more accurate answer with a more detailed x value. So this would be 9.996001. Okay, so we're going to try to come to some kind of like consensus here. The closer I get to -2, from the right side, the closer these values seem to be getting to 10, right? Don't all these seem like they're getting closer to 10? That would be my conclusion that I would make. But maybe you'd want to confirm on a graph. So again, I'm going to graph this function. I'll show you what I did for that. I graphed y equals x squared plus 6. I said basically I didn't want x to be 2, but I had to write it this way. And then I made -2, 10, an open circle, which you wouldn't really have to do that, but I did that just to make it better for you guys. And then I did make -2, 0, its own little separate point down here, because it did say in the function that -2, if that were x, then y would be 0. So it's like this other, defined point that's somewhere not on the curve. So we're approaching -2 from the left side. So I kind of click and hold, and I get closer and closer, and I'm looking at those y values. You're watching, look at the y values. They're getting closer and closer to 10. Obviously, it's not defined right at 10, but it's getting closer to that. So 10 is a good answer. All right, haven't showed you one like this before. So this one, we're going to actually, we can do all this by hand. The difficulty lies right here. This is taking a binomial and cubing it. So essentially, this is just like an algebra question on steroids, because you're supposed to be doing x plus h to the 3rd power. And so we have to work this out to simplify and just kind of hope that things will cancel. The reason why I have to do that is because I can't just plug 0 in for, this one is for h. I can't plug 0 in for h because that would give me a 0 in the denominator. So my goal is to try to do algebra in some way to simplify it down, and get things to change or cancel or whatever. So to multiply this out, I'm going to start by multiplying these 2 of the binomials. So that would be x squared plus 2xh plus h squared. And then I have to multiply that by x plus h. So it's just basically going to look like a nightmare, but just kind of hang with me. Let's see, it would be x cubed plus x squared h plus 2x squared h plus 2xh squared, I'm just distributing, plus xh squared plus h cubed. Do I have everything? X cubed should be 6 things, right? X cubed, x squared, h, x squared, h. I think I got it. Okay, that's an h. So you have all this stuff. That's what you get when you multiply x plus h quantity cubed. And then we're going to kind of go through and we're going to bring down the rest of the stuff. So there was a minus x cubed all divided by h. Like this. And then right away I noticed that these x cubed values cancel, but really nothing else does. So I don't think I even have like terms here, do I? Do I have like, I do have a few like terms. I have x squared h's, 3 of those. And I do have 3 of the x h squareds and x to the, h to the 3rd. Okay, so we're still at this point where we have an h in the bottom, and I still can't plug and chug because then I'd still get a 0 in the denominator. But what we do have is we do have something that you could algebraically manipulate. It may not be obvious, but do you see the top? They all have h's. I can take out an h from each term on the top. And then if I do that, it's going to allow me to cancel the h on the bottom and leave you with 3x squared plus 3xh plus h squared. Okay, so that was a lot of work, but what you're going to do now, finally, after all that algebra, is you're going to try to do plug and chug. So you're plugging in h approaches 0, so all of the h's become zeros. Like this. 0 squared is 0. All this stuff multiplied by 0 is 0, so you're getting 3x squared. That one's not really solvable on a graph because you've got x's and h's, and your graph is not going to understand this like extra variable here, so this one you kind of have to do by hand. But there's no other ones like it on the page or the assignment, so hopefully that helps. Then we get to this guy. This one is one that you do have to do, but it's at the very end. And I did find a mistake with the answer or the assignment document. So this one, you have to just graph it, okay? There's really not a good way to do, there's not really a good way to do this one by hand. This, by the way, this is called a greatest integer function. Honestly, you don't see it hardly ever in math. That's why we haven't really talked about it this year. Basically, it takes functions, or it takes x values. When you plug them in, it gives it the greatest integer that's closest to that value. It's like weird. It is sometimes called the ceiling function. So I just made a graph on Desmos, and I'm just giving you this answer because it's just a strange one. It's called the ceiling function. That's why I have it typed in as here. And so it said we're going to take the limit as we approach 7 from the left. So let's see. As we approach 7 from the left, as I was saying, let's see, it looks like you're getting closer and closer to 0 when you're coming from the left side. If you were coming from the right side, you get closer and closer to -1. But 0 is not an option on your maze. 0 is not an option. Here's the function. -1's not an option. I'm telling you that you're just going to go from here straight up to the end and you're done. Okay, it's 1. This should not be a 1. This should be a 0. So I'll have to go in and fix that later. But for now, I'm just telling you go straight from here up to the end and you are done. Hopefully this helps. If you still have any questions, feel free to reach out. Bye.